Hi guys, this is our first video on statistics and we're going to start off with some vocabulary, and if I move too fast for you, remember you can pause this video and um, write down anything you need to. So the first thing that we're going to set up is some vocabulary. The first thing we're talking about is an experiment, which is an investigation or procedure with varying results. An example would be flipping a coin. An outcome is a possible result from the experiment. So when we're flipping a coin, an example of an outcome would be heads. The sample space is the set of all possible outcomes. So assuming that we are flipping a regular coin, our two outcomes are heads or tails. So some examples of that are give the sample space and number of outcomes for each experiment. And the experiment here is that a state that begins with the letter O is chosen. Well, there are 50 states. 3 of them start with the letter O, so there are 3 possible desired outcomes, and they would be Oklahoma, Oregon, and Ohio. Then our second experiment would be that a day of the week is chosen. Well, there are 7 possible outcomes: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So all of the days of the week are a sample space with 7 possible outcomes. So probability is a measure of the chance of a specific event occurring, noted as P, which stands for probability, parentheses around E, which stands for event. So here, we're going to express that as a ratio of favorable, or the desired outcome, to the total number of outcomes. This ratio can be written as a fraction, a decimal, or a percent. The sum of all the probabilities in the sample space is equal to 1. For example, here we're going to give each probability as a fraction in simplest form, which means you have to reduce them, a decimal, and a percentage. So if you don't know how to do this, there is another quick video attached to the readiness assessment assignment that talks about converting fractions to decimals and to percentages. So here, the spinner below is used in a game. If it is spun once, find each probability. And so we're going to write the probability, that's the P, of our desired event, that's the 9 in parentheses. So when we look at this, we have 9. It occurs 1 time. So 1 over 16, because there are 16 possible outcomes. Then when we write that as a decimal, it is 0.0625. When we write that as a percentage, it's 6.25%. On B, we want the probability that it is at least a 12. So that means that 12, 13, 14, 15, and 16 are all desired outcomes. There are 5 desired outcomes. There are still 16 total outcomes. So the probability that it is at least a 12 is 5 out of 16, 0.3125, or 31.25%. On C, the probability that it is a perfect square is like 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16. So there are 4 possible squares, or perfect squares, on this spinner. 4 out of 16 reduces to 1 over 4, so 25 hundredths, or 25%. D is the probability that it is not shaded, which would be 12 to 2, so 1, 2, 3, 4, 5, 6, 7 possible sections that are not shaded out of 16 total sections, for 0.4375, or 43.75%. On E, we want the probability that will be a 2 or an 11. So there's 1 section that is a 2 and 1 section that is an 11. So 2 out of 16 reduces to 1 out of 8, which is 125 thousandths, or 12.5%. On F, you want the probability that it is a multiple of 5. So that would be 5, 10, or 15 are your 3 possible desired outcomes. So 3 out of 16 is 1,875 ten thousandths, or 18.75%. So on these, I'd like you to try them first, and you can pause on the screen and work them out. Or, but if you get stuck, the answers are up next. So a month of the year is chosen at random. Find each probability that it starts with J. So you have January, June, and July. 3 out of 12 simplifies into 1/4. And then the decimal and percentage equivalents are there also. Then we want the probability that it starts with a T. No months start with the letter T. So that's 0 out of 12 for probability of 0 or 0%. And probability that it has at most 30 days is 5 out of 12. On our second example, the probability, a letter from the word probability is chosen. So for A on number 5, it's the probability that is a B. Well, there are 2 B's out of 11 letters. So 2 out of 11. That is a vowel. Vowels are A, E, I, O, U. So we have O's, A's, and 2 I's. So there are 4 vowels out of 11 letters. And then the probability that it is a Y, that is 1 Y out of 11 letters. So now we have some more examples. Again, pause on this screen and try and do these yourself. We're looking at a pencil box now and a deck of cards. So here, a pencil box contains colored pencils, so the probability that it's yellow. There are 24 possible pencils, and I added those all up to get 24. 6 of them are yellow, so 6 out of 24 reduces into 1 out of 4. That they're blue or purple, I added the blue and the purple colors together to get 10. 10 out of 24 reduces to 5 out of 12. And then CP is not orange, so that would be all of the colors but orange, which is 21 out of 24, which reduces to 7 out of 8. Then we have cards. So the probability that you will draw a queen. There are 52 cards in a standard deck. There are 4 queens. That reduces to 1 over 13. The probability that it is a red 3, well, there are 4 3s, only 2 of them are red. So that's 2 out of 52, which reduces to 1 out of 26. And the probability that it is a spade, those are one of the black cards with, they don't look like shamrocks, the other ones. So the probability that it's a spade is 13 out of 52 because there are 13 cards in every suit, which reduces to 1 over 4. All right, so then we have complements of an event. And the complement of an event is the probability of an event not occurring. Since the sum of all probabilities in a sample space is 1, the probability of an event not occurring is referred to as the probability of not E. This one little squiggly line here refers to the word not. And to find that, you're going to do 1 minus the probability of the event. So here, if we look at number 8, if the probability that it will rain tomorrow is 3 out of 8, what is the probability that it will not rain? So we're going to do 1 minus 3 over 8, and that equals 5 over 8. Again, we've written it as a decimal and a percentage. Number 9, the probability that someone will win a game at a carnival is 1 out of 24. What is the probability that they will not win? So 1 minus 1 over 24 is 23 over 24. And then again, decimal and percentages. Number 10, a number at random from 1 to 20 is chosen. What is the probability that it is not prime? There are 8 prime numbers from 1 to 20. 2, 3, 5, 7, 11, 13, and 17, and 19. 1 is neither prime nor composite. So 1 minus 8 over 20 is 12 over 20, which reduces to 3 over 5. And then if a state is chosen at random, what is the probability that it does not begin with the letter M? 8 states begin with the letter M. So if it does not begin with the letter M, that would be 1 minus 8 over 50, which is 42 over 50, which reduces to 21 out of 25. If we think back to our probabilities here where we looked at not orange. Some of you, when you did this, may have added up the red, yellow, blue, and purple pencils and gotten 21. Some of you may have actually done the reverse probability where you looked at it and you just took 3 from 24 because that's how many orange crayons there are or colored pencils there are. So you did the not probability all by yourself. So good job. So that's it for basic probability. We'll keep expanding on this topic over the next couple of weeks. Hope you guys are having a great day.